Hi everyone, welcome back. We just learned the integral test. So now we want to use the integral test to determine whether a series converges or diverges. So now, example 1, this series is a n over n squared plus 1 from n equals 1 to infinity. So first of all, we write f of x as f of n, right? So here f of x is x over x squared plus 1 as x greater or equal to 1 for all the x are greater or equal to 1. So we need to find if fx satisfies the condition or 3 conditions of the integral test, then we can use the integral test. What are the 3 conditions? First one, if f of x is positive. Second one, if f of x is continuous for all the x greater or equal to 1. 3, if f of x is decreasing on this interval. Okay, so let's see. F of x obviously is positive and continuous for all the x greater or equal to 1. So the second, we need to find if f of x is decreasing for all the x greater or equal to 1. Okay, how do we find the f of x is decreasing? We use the knowledge we learned in calculus 1, find the derivative of f of x. If the derivative of f of x is less than 0, then f of x is decreasing. If derivative of f of x is greater than 0, then this function is increasing. So now we find the derivative of f of x. Denominator square, numerator, find the derivative of numerator times the denominator, minus numerator times the derivative of the denominator. Okay, denominator is x squared plus 1 to the square of x squared plus 1. Numerator, derivative of x is 1, so x squared plus 1 minus x times 2x. X times 2x is 2x squared. So the top is negative x1 plus 1 divided by the square of x squared plus 1. So of course less than 0. Why? Because denominator positive, numerator for x greater or equal to 1, the top is the 0, right? So this is less or equal to 0. And for all the x greater or equal to 0, equals 1. Okay. So therefore, f of x is decreasing. Or we called actually, so here is a no increasing. For all the x greater or equals to 1. Okay, so now, which means f of x satisfies all the conditions in the integral test. Now we find the improper integral. If the improper integral converges, then the series converges. If the improper integral diverges, then the series diverges. So we find the improper integral. okay, equals right limit, okay, equals the limit as n approaches infinity, 1 to n, or you write b, right? So we learned in 8.8, doesn't matter which letter you use. Okay, so then we approach infinity. So x squared plus 1. So we use a substitution method. We can use the d of x squared plus 1. D of x squared plus 1 is a 2x dx, right? So this we multiply by 2, divide by 2. So let me write it. So that's 2x, then divide by 2 dx. Why we multiply by 2, divide by 2? Because we want to write a 2x dx as a d of x squared plus 1. We put a 1/2 outside. So then here, x squared plus 1, d of x squared plus 1. So then we can use log rule, okay, log rule. Equals 1/2 limit as b approaches infinity, ln of x squared plus 1, ln of x squared plus 1 from 1 to b. Okay, equals 1/2 ln of b squared plus 1 minus ln of 2. As b approaches infinity, ln of the b squared plus 1 approaches infinity. So this limit doesn't exist, it's infinity. Okay, so therefore, diverges, right? So the series n divided by n squared plus 1 diverges. Okay, so there's another example. I want to click pause here. I want to solve it on your own. Okay, welcome back. So diverges or converges? Yes, diverges. The answer is diverges. Okay. What is fx? F of x equals 1 over x times the ln of x. So in this case, x greater equals to 2. So now we need to find out if this function satisfies the condition of the integral test. So first of all, yes, greater than 0, positive, yes, continuous, when x greater or equals to 2. Right? Okay, so now decreasing or increasing, we don't know. Find the derivative. Okay, we find the derivative. How to find this derivative? This is a composite function. Use the chain rule. Okay, you write this fraction as a negative exponents. Negative first, negative exponents. Okay, so then find this derivative of this equals -1 times x ln of x to the -2nd. And multiply by the derivative of this function because of chain rule. Okay, you think of this as a big U. So first of all, f to u, derivative f to u, then times the derivative u to x. Okay, so here's a -1. You write this square, the 1/, square of x times ln of x, then times another chain rule here. So derivative of x times ln x plus x times the ln x derivative ln x to x, 1/x. The answer is a negative. Denominator, the square of x ln x. Numerator is a ln of x plus 1. Less than 0 for x greater than 2. Okay, so now, therefore, satisfy the condition. Conditions of the integral test. We find if the improper integral converges or diverges. This equals limit as b approaches infinity, 1 to b, 1/x ln of x dx. Okay, so we can rewrite this 1/ln of x times of 1/x dx. Think about this. This you can write d of ln of x, right? So you think of the u right now is a ln x is u. So equals limits as b approach infinity. So here I rewrite again d of ln of x. Okay, so equals limit b approach infinity. How much is this? This is the ln of x, right? From 1 to b. So equals limit b approach infinity ln of ln b minus ln of ln 1. So as b approach infinity, this part infinity. And this is a 0, right? This is 0, ln of 0. So we don't have to think about this part. We only think about this part as infinity. So we rewrite it. So here there's some error here, should be 2. Okay, should be 2, okay. All right.